Hi, this is Rahul Sharma. I am the student of Master of Engineering Cybersecurity, University of Maryland College Park, and this demo is for ENPM 686 Information Assurance Spring Semester 2019. Today I'm going to give a demo on OWASP Z Attack Proxy. It's an open source tool for penetration testing developed by Open Web Application Security Project. The victim application we are going to use, it's called OWASP ZAP, and we are going to launch this application on Heroku. So this is the application which has a lot of known vulnerabilities, and today we are going to exploit some of the vulnerabilities using ZAP, Z-Attack proxy, as well as we are going to do some analysis outside ZAP to see what all those vulnerabilities are. This is the ZAP uh, interface. We can launch an attack by spidering through the web application, or we can go in depth by launching a browser and navigating the application. And what ZAP is going to do is it's going to record all our actions and provide some alerts about the vulnerabilities it's able to find. So I'll start a automatic attack, and I'll choose the attack mode, which means ZAP is going to send some payload to the application, and and it's an active attack mode. So the difference between active and the passive attack mode is when we are in the passive attack mode, ZAP is not going to send any payload. It's just going to scan the application and give some hints and give some suggestion to improve the security of the application. So right now we have launched an automatic attack, as well as we have put the ZAP in attack mode. That means it's sending the payload to the victim application. It takes some time to scan the whole application. So what I'm going to do is I already scanned this application and produced a report. So once the scanning is done, we can go to the report bar and generate a HTML or other format report for later on for us to review. And these are some of the suggestions that ZAP has suggested. Since the time is limited, we are not going to go through all the items in the report. What I'm going to do is I'm going to stop the test, and we are going to explore the application manually. As you can see, we have launched a Chrome browser using the launch browser button on the ZAP, and whatever we are going to record on the Chrome, it's going to get recorded on the ZAP. So one of the vulnerabilities is in most application is SQL injection. So what we are going to do is we are going to provide some random character to try to log into the application, and it gives us some error message. And I checked the top 10 document by WASP, uh, and it says that many applications do not handle a single quote gracefully. So that's what I'm going to do, and I put the single quote here, some random character in the password, and we can see that there is some a weird message appearing on the UI. Then I'll go back to my ZAP, and I'm going to see what that message is. So this was the first payload we sent to the application. The response we got was invalid username and password. Second was when we sent the single quote, we got some weird object, comma object. And when we go to the response, we can see that a SQL is being revealed by the application, and that's not a graceful termination of an error. Next, what I'm going to do is I'm going to use a fuzzer, which can be used to send a lot of payload to the application and analyze the result. So I'm going to pause the video, but one of the payload I'm going to send is the typical SQL injection by using a single quote or 1 is equal to 1, which is always going to be true, and comment out any other statement, SQL statement inside the application. I'm going to add this payload, and I'm going to develop some other payloads too. I'm going to pause this video briefly. The payload is ready. I'm going to start the fuzzer, and we can see that one of the payload is a typical SQL injection, and the response we got was 200. That means our SQL injection uh, uh, actually we were able to successfully carry out SQL injection, and the application revealed a admin user ID. So what I'm going to do is I'm going to log in as this admin using the UI. So I'm going to use the same SQL injection we used using the fuzzer, and I'll provide any junk password and try to log in as an admin. And you can see that I am able to log in as an admin. I'll go to the administration page, and as you can see I'm logged in as an admin. I can do a lot of harm to this website by deleting all the comments. I can see all users which are logged in, like which are registered to this application, and this uh, I'm able to do it by carrying a SQL injection. The second attack I'm going to carry is I'm going to log in as one of the user, and I'm going to see other users basket. So right now I'm logged in as a normal user, def@def.com. I'm going to add some products in my basket. I'm going to go to the basket, and at the back what's happening is OWASP, uh, it's recording all the activities. So I'm going to pause this video. I'm going to actually show you what happened when I went to the basket. You can see that there is a URL basket, and there is a number behind just after the basket. So what I'm going to do is I'm going to send a lot of payload to the application and try to see if this application handles um, the payload correctly, and without revealing some other person's basket. So while I'm developing a payload, I'm going to pause the video. So what I have done is I've gone to the fuzzer, and I've selected this value which I'm going to fuzz. I'm going to add, and I'm going to add the value, and it's going to be multi-line. So what I'm going to do is 1 2 3 4 5 6 7 8 9 and 10. So I'll click on add, and start the fuzzer. Let's see what we get back. So after fuzzing all these values, one of the value we were able to get the positive hit, which is when we have number 2, we are able to see some other person's basket. As you can see that this person has added made from blended Raspberry Pi, water and sugar in their basket. That's why uh, all like it's a sequential increase. The application is increasing the basket by 1, and we are able to hack the application just by fuzzing some of the values. That's why high entropy in uh, is very important, instead of just increasing the value by 1, which is very predictable. Next one. So what I have done is going through a UI, I registered a normal user and OWASP recorded my action and there is one of the API. What I'm going to do is let's uh, analyze the response. As you can see that in the response there is a field called is admin is equal to false. So what I'm going to do is I'm going to modify the payload and put is admin is equal to true. There is for a normal user this parameter is missing, so we are going to change this JSON and try to see if we can get a entry from the backdoor by exploiting this application register and a user as an admin user. While I'm developing a payload, I'm going to pause the video. So what I have done is I have used the request for a normal user. I have copied the request and analyzed the response. There is a is false is admin as is equal to false. I went to the requester, copied everything. What I have done is I put is admin is equal to true. Let's send the request. I sent the request. Got I got the positive response back. Let's see if we can use this user and able to log in as an admin. So what it shows is we register a user through a backdoor by changing the payload, and we are able to register this user as an admin user. We can verify this is an admin user by going to administration page. And yes, a normal user is not able to access this page, but since we are able to register this user as an admin user, we are able to go to the administration panel and cause a lot of damage to this application. The last thing I'm going to show you today in this demo is the report we generated using the automatic feature of the ZAP. And we can see that there are a lot of vulnerabilities. It also found that there are other pages where the SQL injection is possible. And what generally people do is once the report is ready, they discuss it with the app dev team. And some of the vulnerabilities are just changing the header of the application. And we can see that ZAP is able to find, ZAP is giving a lot of suggestion to improve the security of the application. Um, what I'm gonna do is um, what happens is some of the suggestion that ZAP give, it may not be 100% accurate. For example, it's saying that there is a timestamp disclosure, a Unix type timestamp disclosure, but I checked the application in my ZAP panel and it's a false alert. So we have to analyze after ZAP gives the report, we have to analyze and fish out all the false alert and only act on the alerts which looks like these are the real vulnerabilities. This completes my demo. Thank you. Bye.